Yep, so that's what I saw also. We're just generating all mating positions. Black is mate, black is mate. This one is ordered before that one. And I don't understand that because the black king is not on the same position, so it should be looking at just the black king. They are both on this diagonal, which means it should just look at the M coordinate, which is the vertical coordinate, and then the smallest one is the 0 here. King here is at 0 and the king here is at 1, therefore this one's less. This one should be ordered before that one, not the other way around. Now we have something that reproduces super short, so I can run it in GDB. It's in chess. GDB. The thing. and then I guess break main or something, run, next, print, and now we're going to step into distant less. Now the first board, this one, is flipped. Why is it flipped? Because the black flip basically means that the rook is in this triangle instead of in this slightly larger triangle, including the main diagonal. So this is not flipped and this is flipped. Okay, this is flipped. Board is passed. This is false because that's the argument that is being passed. Which is board 1, which is this board, which is not flipped. Next, print, flipped. Is false. Yay. And then flipped is the one of board 0, what this was called on. So this one is true, as expected. Furthermore, the one that is not flipped, so that would be board, right? This is false. Stores the coordinates of the pieces as they are. As in, this one stores 1-0 for the black king. Black king 1-0. And the 1-0, and then the white king is 1-2. White king 1-2. And the rook is 3-0. Rook 3-0. Yes. To play black flipped is false, etc. Well, the other one, the current object, has thus flipped 2 and therefore swapped all the coordinates. So instead of, this is board 0, so instead of storing 0-1, it stores 1-0 for the black king. Yep. And instead of storing 2-1, it stores 1-2 for the white king, 1-2. And instead of storing 0-3, it stores 3-0 for the rook. Yay. Black still to play, flip true. Everything so far correct. Now we're going to look at if the black king, and that's the only thing that matters, is less than the black king of the other of board 1. Is this the case? Well, it should be the case, and then it isn't, or the other way around. So what it should it be the case? PK is the current object, and the current object is this one, which is board 0, which is this one, which is less. So yes, this should return less. It should return true, I think. If it returns true, then that means that board 0 is less than board 1. Because the argument of this function is board 1 and the current object is board 0. This is how it is called. And that's what I want. This is less than that one, right? No, it's not what I want. Sorry. I want that this one is less. It should be the other way around. Okay, sorry. Yeah. So board 1 should be less than. So this says, is board 0 less than board 1? And this should return false. But it returns true then, I guess. Let's step into it. That calls distant less on the positions of... I keep forgetting not to remember too many things. So this is board 0 and board 0 should be larger, right? So this should return false, yes. Let's just check the values again. So pos underscore is the position of the black king of board 0. Why board 0? Because it belongs to BK, which belongs to the current object, which was board 0. And board 0 is, well, I just printed it. That would be, that is the current object. So that would be this one. The position of the black king, that is 1, 0. Plus it's flipped to the, and this is the left hand side. So the left hand side must be true. Yes, so everything is passed correctly. Well, not everything, but what I checked so far. And then this is the position of the other king. Oh, this is also 1, 0, right? Because, but they're not flipped. The other king, namely, belongs to board 1. It's this one, which is not flipped and stored in 1, 0. So it is 1, 0, but in this case we have the right hand side, which is false. Okay, so all the values are what I would expect. And this function should return, because we are comparing board 0 is less than board 1. And actually that is not true. So this should return false. Step. Now we are inside the position. Okay, now n plus m, whether or not it was swapped or not, is 1. We do next, and then the sum is 1. The other sum must be equal. So yes, that also 0 plus 1 of the right hand side position. Next, the other sum is also 1. Therefore, the sum is not what it determines. So the sum is less than, nope. Yeah. The other way around, nope. Therefore, we return value true or false based on the value of m. Meaning, if it is not flipped, then if this is false, then we use m. This is false, then we use m. And we compare if m of the current board is less than the right hand side. Left hand side is less than the right hand side. Now the actual m coordinate is what we see here being printed, and we are comparing, we should be comparing board 0 is less than board 1, right? And that should be false. Now board 0, the m coordinate of board 0 is 1, and the m coordinate of board 1 is 0. So we should say, is 1 less than 0? No, that's not, so it should return false. So again, the left hand side is the board 0, which is flipped. So this should be true, and the other one should be false. And then because this is true, we use n, so n should be 1. I have the feeling that it is, oh, actually it is 1. Okay. And here this is false, so we use this value, which is 0. What the fuck? So this is going to return false correctly. Flabbergasted. Finish. it returns false. So board 0 is not less than board 1. It says that's what it returns here. Although the program was telling me the first board, aka board 0, is ordered before, aka is less than the second board. But so far, yeah, I don't know. False is being returned. Do we finish here? Also false, of course. Okay, so this is false. Well, I agree with that. Which means that we're going to the next one. Now we compare it exactly the other way around. That is, before I compared BK is less than board BK. Okay, we found the error. Yep. So I flip the boards, which means that I also need to flip the flips. Because the first flipped corresponds to the object that we call it on. Board goes with flipped, and the current object goes with flipped underscore. And then here again. That should fix it. No, it doesn't print it, so it has been fixed. VI, internet chess. Well, we are done with this now, I guess. Unless I have to compare to others, but probably are done with this. So the king in the corner is ordered before everything else, and then we get, yep, now we get first the king as high as possible. And then the rook moves, and then we get this one, because the diagonal is more important than the x-coordinate. So it moves over this diagonal, and it moves from top to bottom. Okay, looks good. Good. Then now we have stored all positions that are made. Already made. So next I want to run over I'm going to reuse this. Actually, this is what is doing that, this whole block. Let's store in data at the very least the number of moves. Oh, it's just in data. .h. So I'm going to store here the number of moves that it takes to give mate. Let's say I'll call it ply. So now we need to store apply equals 0. And when putting this in the map, as in here, and you can try and place simply add, sorry, the arguments that are required to construct the data. So this should work with just an int, I think. Let me try that. Or not. Not even sure. No, it works. Okay. Now I want to run over all these positions and then generate all positions that can be one move before these positions. Let's see, how are we going to do that? I guess having a loop would be nice. So we have a loop, and then inside the loop we have a position that in one move can reach the board of that one. That can reach the current position. And then we have to do some checks, right? It could be that the thing already exists. If it already exists, then it is possible to make it faster. So then that's just not corresponding. So I'm going to have some kind of loop. Well, which gives me boards. I don't know, let's call it board. So we have board, and then try to find it in the map. I just want to know if it exists, I guess. Or no, not if it exists. I really want to find it if it exists. So I'm going to get an iterator boolean pair. From data, that's the map. I'll find board. Let's check if that is the case. map find find returns an iterator. So we can search for the key and then we get an iterator. It's not an iterator boolean pair. So if it did exist, then it is find returns something that is not end. Then I want to continue to the next one. That's just not a position that comes before. If it did not exist, then this position is a position of one ply more. Except, of course, when depends on whose move it is. It's possible that that we find a position in which black is to move, and black can do a move such that we end up in the current position. But that would not be a very smart move. Black would also have another move in which the number of moves to give mate is much larger. I need some kind of a recursive function, which means that I should not add it here, but call a function that I can implement recursively. Thopstrix, is that a side project? Yeah, I guess. Just started it 3 days ago. I hope it doesn't take too long. We're just curious. Should return to neural networks, I think. That's what it was actually working on. Everything in between was a side project. It distracted me for a few months. It's ridiculous. I think the idea is that I have all positions that are already made, aka made in 0 ply. And next I want to add all positions that are made in 1 ply, and then all positions that are made in 2 ply, and so on. And that sounds like recursive, as in Maybe not recursive. But still, I need a function, I think. Okay, let me think. Closing my eyes so I can think. I think I need, and I will start with something that returns a vector with all positions that can reach the given position in one ply. So we'll postpone this. If, and I'm going to do some kind of vector. Well, now I can reuse my positions. Positions is still need to loop over this though. That's plural, I guess. So this vector will be filled with all positions that can reach current position in one ply. And after having that, I want to print that as a test. I mean, so I can check it. So I'm gonna print. I just printed. Whoops. Board print. Separator. I might as well delete this. Doesn't contain that much. Okay, I have to write the reverse moves. Okay. Put on some music. The inverse of to play, is that too ugly? Switch is a keyword. Actually, it should already work. Right, so if to play equals black, then stuff. White is easier. Okay, well, white is to move. That means that the black king will not move. So we know the position of the black king. Yeah, same thing here actually. If black is to move, then we know the position of the white king and the white rook. Possible moves depend on, so in this case, maybe this one is easier then, sort of. So we can loop over all positions of the black king. And the reverse move is really the same as a move, so I might as well use a move generator. I mean, we only have kings and rooks, so it's completely... the check rules and stuff change a little bit. You can move into check now. But I have to consider, say... let's call this the king moves. Generated from the black king position. Yeah, the black king was up front. This is the constructor of a board. The black king, white rook. And more. The color to play and then whether or not it's flipped. Well, in this case I just don't care about that, so I don't pass anything. Just the color to play. And then it's of course what we calculated to play. I think I can already test this as soon as I wrote that. Not sure if this is going to work. I think that's all we need. A beginning and an end. Now we need more. This must return an iterator, obviously, that I can increment. Oh my god. No, let's king. No, nonsense. Let's king moves just return. Which one? Well, the black king. If 2 plays black, then the black king. So that should be like that then. Yeah. And we get the legal reverse moves. It's not really king moves then. I could call it the legal king. Legal king reverse moves. Or something. Whatever. No matching constructor still. Oh yeah, blah, blah, blah. What? Oh, I'm passing the black king. Yeah. I'm passing the black king here. Yeah, I have to pass the board if I want to check for legal moves. Yeah, okay. Okay. Can pass the board, but it should return positions, I think. Yeah, let's call this n anyway. The x, right? Yeah, see, that's what I mean. Already made a mistake. N is horizontal. That would be nice. You can add this to the vector. In the end anyway. I'll still need more tests, but let's add it. That thing called previous, yeah, previous positions. What the hell? Previous position isn't vector. It's not insert. Push back. Previous position. But I don't want to add the. I don't want to add anything illegal. So. When is this an illegal move? Well, I think, well, move. I think it's illegal if the resulting position was illegal. So we cannot move from an illegal position into whatever the position is that we are being passed here. Simply don't generate illegal positions. And I don't want to check that here. We just have to add a member function to board for checking illegal positions, I think. Which means that I have to put this in a board. Ugh. Which is the actual previous position. So make a previous position which starts at board. And then I can update board. As soon as we found the previous position, although it depends again on which color, unfortunately. So we do if color is black. Not even sure we can update it. I can't. Well, I want to. Oh. Two variables of the same name. The position is both the position of a piece, but also a position is also the whole test position, all pieces. Stupid. So let's call the whole board position just a board. Or I could call this, not, it's still dubious. No, what is the word? Ambiguous. Could still read previous position as meaning the whole thing. So let's rename both then. And now we can check the previous board is legal. Continue. No, still have to implement now is illegal as well as these. And these are simple to do. Though they take a position and they are a member function of board. Can also not access that. Now let's add the accessor for that. No, it's NM. Not pos. Actually, it's just that. The white king position becomes white king position. Okay, still need to write the is illegal now for a board. Guess that is this block of code. Pretty sure this updates board underscore. Yep. In the end, this is just go board underscore is illegal. Continue. It's not printing anything. Printing all the current positions, but not the result. So the king moves apparently stay empty. That's kind of strange. So run over all the mate the stuff that is where it is made, and then we print that. And then we call reverse moves, and that returns apparently an empty vector. Or not. Oh, actually, it is the case, yes. Maybe we get here and I do nothing. But I think we should be here, which means that this returns nothing, so that we never put anything in the results vector. Or not. Okay, so the current position, this board here, is mate. That means that black is to move but can't move, which means that the position that we came from was a position where white was to move. So, oops, yeah, this is not done. We're doing this and adding nothing. This should generate something, maybe? No, it doesn't. And since it is a mate position, it's not possible for the white king to have come from a place where it blocked the rook. In other words, the rook is still giving check, no matter where the king comes from, and that is an illegal position. So this should return nothing, and we should still add nothing. Just test it, you know, like, why not? And yeah, that's not the case. So that's then wrong, I would say. generates a shitload of stuff. Just look at the last one. Current position is this. And then we could have come from this position. But no, I don't think so. The flip is not set or something. I'm constructing the thing without the correct flipped. Flipped is never set. Yeah, this is also very interesting. The white king. Oh yeah, that is possible. The white king is somewhere here. So yeah, the illegal move is not being captured, it seems. Illegal position. So if this is an illegal position because white to play and white could just take the black king. But that is apparently being ignored and the king is just moved there and then we get the final mating position. And here the king comes from somewhere outside of the board. And another one outside of the board. And here we can move from there to there. And we can move from there to there. And yeah, only king moves, right? But all of those positions are illegal. So two things. King should not come from outside the board. Outside the printed board. So just test the limit, I guess. It's going to be N, that is the horizontal limit. So that should get rid of the last two positions that you can see here. Yes, it does. Now the king is always on the board. There is something wrong with the flip as well. I think that unless the black king is moved, flip should just stay the same. To recalculate the flip. The flip is the same, isn't it? This is the copy constructor. Oh, wait a minute. Oh, wait a minute. I'm just pushing back positions, yeah. But. I wish I hadn't done the flipping, because at most it speeds up a factor of 2, but it's difficult to code it. Yeah, maybe it speeds up more than 2, but like if we have an n times n and n is half, then it's a speed up 4, right? So at most a factor of 8 then, but probably not even that. Okay, forget about the flip. I need to detect legal positions, which clearly goes wrong. Oh, this updates the king position, but not the move. So I have to toggle who is to move. Still bloody is not working. No, it never wants to come. It doesn't even want to come from the same column. What? only wants to come from 3, not from 4 or 5. Doesn't make any sense. Oh, I think I see it. It thinks that this is legal because the king is in between the rook and the black king. Haha. That's what goes wrong. So the king is not next to the king, therefore it's the king that's not illegal. But at the same time, it thinks that black is not in check because it thinks that the king is there. Just checks the horizontal thingy. Right, so the illegal check thing is wrong, yeah. Or the board. Yeah, board. That would be here. White is to move, and the black king and white rook are on the same row. And the white king is not in between them. If white to play, is the black king on the same row as the white rook, and the white king is not in the middle. And this only tests the end position, so I should test M as well. How do we do that? What the hell? It still doesn't work. It's still doing the same thing. It still thinks that the king is in between. What? I need to test the exact the other one, the other coordinates. So if this is M, then we need to use N here. Finally, now we have no legal positions whatsoever. Yep, very good. Where are we? Oh yeah, you are here, King Moose. No, we are not King Moose. Hopefully the compiler won't complain that I'm hiding something by declaring WK again while it already exists. But well, in that case I'll just shut it up. Or I can rename them, of course. Like put a C in front of it as const. Or maybe not const, but like previous. And I'm generating the previous current. The C of const and current. Can't get it any better. So we run over BK here, and then the other two are constant. You run over WK to these are constant. We run over WR, so the kings don't move. And then I have the right rook moves. Yeah, more updates. I mean, this is running from. Shouldn't do a DN anymore, I think. No, I should not do that at all, actually. I simply have to run from for a new n from 0 till the limit. think that's all. Well, apart from the perpendicular thing. So if the rook is moved horizontally. Oh, wait a minute, it's a little bit more complex. We cannot move through a piece. I should probably use 2 loops and just start at the current position. Go in one direction, and if you hit another piece, then stop. So that in total we get 4 loops in. Otherwise, yeah, I think I'm going to bed. I mean, I can continue, but it just gets too late. I'll continue tomorrow. Hamza, if you're still here. I can see that, I think. Participants. Nobody here. Well, 2 people are here, but nobody who did talk. Anyway, text editor, yeah, new Vim. I'll be back tomorrow. Good night.